Bismillahirrahmanirrahim. Welcome to the new lecture. It's the third part of your chapter number 5. So it continuity of chapter 5. So this is analog and digital. So now coming to analog conversion. This is basically analog to analog conversion. So analog to analog conversion is the representation of analog information by analog signal. What something people can ask, why we are changing analog to analog? We have analog signal. Why we need to be converted to analog again? Because as I told you in recent lectures that we have a different kind of filter. We have a band pass filter. We have a low pass filter. We have a high pass filter, and same like for a medium, band pass, medium, high pass and low pass. So once we have a signal of a low pass and our medium is a band pass, so what we can do, so we need to be converted. So for that conversion we are saying that we need to be, once we have analog signal and we just convert analog to analog, because of that our medium is going to be low pass or maybe band pass or maybe high pass. So this is basic reason why we are converting analog to analog conversion. So the topic which we need to be study and which is helpful for a conversion of analog to analog is first is amplitude modulation. In amplitude modulation, what we can do, we are changing the amplitude of our original signal. In a frequency modulation, what we can do, in a frequency modulation we are changing the frequency of our original signal, and in a phase we are just changing the phase of our original signal. So these three concepts we need to be keep in mind for analog to analog conversion: amplitude modulation, frequency modulation and phase modulation. The first one is amplitude modulation. So amplitude modulation, we have a signal, modulating signal, analog signal, original signal, and we have a carrier. So once this modulating signal is multiplied with the carrier, so what the carrier is going to do, the carrier is going to change their amplitude. What is going to do, the carrier is going to change, going to modulate their amplitude of the signal. So at the result we have a amplitude modulated. Now this is amplitude modulated signal. So same as you have a signal, we have a multiplier, we have oscillator, need to have a carrier multiply with, then the result we have a amplitude modulated signal, because the amplitude is going to be changed. And the formula for the bandwidth amplitude modulation is same like a 2B. Okay, and again the same concept, you have a carrier, a central frequency in the middle, and so on. So the total bandwidth required for amplitude modulation can be determined from the bandwidth of the audio signal, and the bandwidth of amplitude modulation is 2B. This is simply a formula. And the total bandwidth required for a frequency modulation can be determined from the bandwidth of audio signal, and this is the formula for the bandwidth of frequency modulation using a 1 plus beta. So now what is frequency modulation? In a frequency modulation we are going to be change or shift the frequency of the original signal. So if you can see our original signal in this form, our carrier is in this form. So what's going to do, carrier, the frequency is going to be changed. Let's see how much is the difference between the frequency now and here. So now how much is the frequency difference here? Too much, too lower. So now what's going to do, it's going to increase the frequency of the signal. So frequency is going to be increased. So once frequency is going to be increased, so your original signal, we have a voltage control oscillator. What he's going to do, he's just going to control number of frequency, the voltage, and so oscillator, and then we have a modulated frequency signal. Okay, one thing need to be have, what kind of a thing is going to be fixed in amplitude modulation? So two things, frequency is going to be fixed and the phase is going to be fixed. These two things is not going to be changed. So what's going to what's going to be happen in frequency modulation? So phase is going to be fixed and amplitude is going to be fixed. So what is going to be changed? Just frequency is going to be changed. Okay, so coming to the phase modulation. So the phase modulation, what's going to be happen here? The thing is, the phase will going to be changed here, and the frequency and the amplitude is going to be fixed. Okay, so just taking one. So the same formula of the frequency modulation for the bandwidth will be used here, but just one thing which is the difference between the frequency modulation and the phase modulation is derivative. We are just using the derivative here. If you can compare this is a frequency modulation. We have just voltage control oscillator without any other extra thing which is added here. Okay, nothing is added here. But in here, in phase modulation, we just add derivative, differential. Then we add the signal with the VC or differential. What he can do, he just make the slope and he just make the changes. Derivative means changes in the slope, changes in the shape, changes in the graph. So that's why you just use a derivative in the phase modulations. Okay, so the same, the total bandwidth required for the frequency modulation can be determined from the bandwidth and the maximum amplitude of a modulating signal in the same as formula. So this was your lecture, so you guys can watch it out. If you have any question, you kindly raise your question on the comments, so I will try to solve it for you. So thank you for your time. See you in the next lecture.